Okay, we're going to do 17 on page 349. It says Stanley would like to give $5 gift cards and $4 teddy bears as party favors. Oh, Shanley, sorry. Has $120 to spend on favors. Write an inequality to find the number of gift cards X and the number of teddy bears Y that Shanley could purchase. Okay, so again, I like to mentally sort of bracket. This is what, I guess that's a he, can spend. And what he can spend is no more than $120. So he can spend up to $120, less than $120. So everything he can spend is over here. It's got to be less than or equal to 120. All right, so $5, they're going to use X for gift cards, and $4 teddy bears, and all of that has to be less than or equal to 120. So once again, solve for Y, let's graph it, and then let's use the graphing calculator just to double check and practice. Okay, so the first thing I did, and I didn't really show my work all that well, but negative 5x, so subtract it from this side, subtract it from that side, and here's what I wind up with after that one step. Then I'm going to divide both sides by 4 so that I get y is less than or equal to something, okay? And I'm going to move over here just a tad. Y is less than or equal to negative 5 over 4x. 120 divided by 4 is 30. Okay? So there's my equation, and now I'm going to graph it. In this particular situation, because it's a real-world situation with money, I'm not going to be able to, it doesn't make sense to have negative teddy bears, negative gift cards, and stuff like that. So I'm going to use one of the little sticky notes that only has quadrant 1 with all positive numbers. Okay, on my y-axis, I went by 3s. So this up here is 30, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. It's kind of hard to see. All right, so there's my y-intercept. And I'm going to go down 5 boxes and over 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Down 1, 2, 3, 4, 5. Over 1, 2, 3, 4. But Ms. Goff, those are actually worth more than just 5 and 4. Yes, but the ratio is still the same. Down 5 boxes over 4. Down 5 boxes over 4. I am going to draw a solid line because it says less than or equal to. Okay, and I actually noticed that I drew a line segment because, again, it doesn't make sense for me to go into negative territory in this situation. I am going to use a checkpoint of 0, 0 still because that's just easy. So if I put a 0 in here and a 0 in here, is 0 less than or equal to 30? Yes. So any ordered pair in the shaded area or on the line will make this inequality true. Okay? Okay, so I told you guys a minute ago, this is just so sloppy, that's a 30, that I went on my y-axis, I went by 3s. Did I go by 3s on my x-axis? Well, I don't know, but I actually do know, but let's look at the equation down here. Think back to module 5 when we did x and y intercepts. If I want to know the x-intercept, I can put a 0 in for y. So all of this becomes 0, and I have 5x is less than 120. Well, when I say 120 divided by 5, I get 24. So this point represents 24 comma 0. So 1, 2, 3, 4, 5, 6, 7, 8. 24 divided by 8, yeah, so I'm going by 3s down here as well, okay? So that just gives you an idea of how you can determine ordered pairs. So for instance, 3, 6, 9, 12, I could buy 15 gift cards and 3, 6, 9, and 9 teddy bears. And I'd still have a little bit of money left over, that kind of thing, okay? Any point either on the line or in the shaded area works.